Hello and welcome back. In this video we are going to perform another activity, and this time we would be looking at the second activity here. So we are to write a C program to compute the multiplication of matrix A and the vector B. So we have this matrix A and then this vector B, right? So let's see how we can go about this and then solve this. So first we have to solve this, we are given matrix A, right? And the matrix A was a 4 by 4 matrix, right, with elements 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20, and the vector B, or the column matrix B, was 1 2 3 4 5. So we are given a 4 by 5 matrix, right? Given a 4 by 5 matrix, and matrix B is a 5 by 1 matrix. So this is a column matrix, and then this. So if you have to multiply these two matrices together, it means that the resulting matrix, say C, would be what? A 4 by 1 matrix, right? So it means I would have 4 by 5 and then 5 by 4. If they should multiply, this would take care of this. The 5 by 1, sorry. Then the resulting matrix will be a 4 by 1 matrix. Okay, so we are expecting that our resulting matrix C, right, should be a 4 by 1 matrix. So which means that to solve this problem, we would first have to declare, right? So, and these are integers, so we first declare an integer matrix A and then assign it, and this takes 4 rows and then 5 columns. So 5 columns, and then another mat B, another integer matrix B, right, which takes this time 5 rows and then 1 column, right? And then declare another integer matrix C, right, and then this takes 4 rows and then 1 column, right? So once we are done declaring these matrices, then we then perform the multiplication. Now let's see how the multiplication is done. If you want to multiply this matrix, right, looking at this, we would first, to do this row multiplies this, right, which means that each element here, this element to multiply this, then plus this element times this element, then plus this element times this element, plus this element times this element, plus this element times this element, right? Okay, now if this is true, and then from there that would form the element, the element in the first row, first column, right? Then the next one would become this. Let me pick the red pen here. So here, now this row, this row will now go back and then multiply this whole column again, right? Which means that the 6 multiplies this plus this multiplying this, plus this multiplying this, plus this multiplying this, and then followed by this row, and then finally the last row also does the same thing. So if that is true, then it means that we would have to loop, right? So we would have to loop through the matrix A and matrix B, and while we are in the loop, we multiply and add the results together and then populate it to a new matrix C. So basically that's how it's going to be, and without wasting much time, let's see how we can start with it. Okay, so we go to our terminal, and then we use our favorite text editor, so Vim, and then this one, let's call it matrix multiplication, matrix more, or math more, right? And then .c. So we then include our standard input output, and then from here our int main function. This returns nothing, so we give it a void. And okay, so now the first things first, we would have to first declare our matrix, and we said it to be an integer, and so we call it mat1, matrix A, sorry, and this takes in a 4 by 5. This is a 4 by 5, so 4 rows, 5 columns, right? And then we want to populate it straightforward. We don't want to write any loop to do that later. So we first give it, we said we have 4 rows, so comma, another one, comma, another one, comma, another one. So here we have 4 curly braces here, and then now the elements in row 1 was 1, 2, 3, 4, 5. Row 2, 6, 7, 8, 9, 10. And row 3 was 11, 12, 13, 14, 15. And then the fourth row we had 16, 17, 18, 19, and 20. Okay, so that's for that 4 rows, 5 columns. And then let's terminate this line, and then the next one we have the int, so we call this mat b, right? And matrix B on the other hand is just a 5 by 1, so 5 rows and then 1 column, 5 by 1 matrix, so 5 by 1 matrix and 5 by 1, and this has elements, so you could do this 5 rows, so yep, so here we put the elements inside. 1 is here, 2 is here, 3 is here, 4 is here, 5 is here. Okay, so 5. So now we are done with this, and then we said that we would put our results in a matrix called C, right? And we said that the resulting matrix would have a 4 by 1 dimension, so we give it that. Okay, so now we are done declaring our matrices. So the next thing we'll do is to now loop through them and see how we can perform the multiplication. So to perform the multiplication, right, so matrix multiplication, to perform the multiplication, all we have to do is loop. So we say that for int I, right, that's an initializer, starts from 0 because the matrices have 0 index, right? They start from an index of 0, and I is less than the first matrix. We said the first loop, the outer loop, belongs to what? The outer loop belongs to the rows, right? So this is the row loop, right? So, and the row for matrix A, there were 4 rows, so 1 to 4, so 1 less than, so I less than 4, and then increment I, right? Then inside the loop we create another loop for the column, so we have a column loop, call loop, and this would be for j, right? So int j equals 0 because it's from index 0, right? And then j less than what? Now there are how many columns? There are 5, so j less than 5. Then what happens? So increment j, so we do that. Now inside this, so now we are now deep inside the loop. We have the loop for the rows and that of the column. So we say that what, since we are performing the multiplication iteratively, we would have to first assign our results. So we call that matrix C, right? Matrix C was equal to, or the elements. So let's see the elements of mat C, right? So the elements of mat C should have the, now let's go back to our sheet and see something. Here we can see that the mat C, right, has 4 rows and then 1 column, right? Which means that the result, right, our result that we would have would be a column matrix that has 4 entries, right? So it means that if, and we saw that the result takes the entry. So if you have 4 by 5 multiplying 5 by 1, right, this takes out this, and then this takes, and then the result takes a 4 by 1, right? So it means that if this is going to be like the I for the C and then the J for the C, right? So it means that should we take, or should we consider any matrix and we should take I and J, then we have to make sure that the I and J's come from this particular side. And then we realize that for the B as well, the J was 1 here, right? And then for A, the I is what? 1. The I is 4. Okay, so what then is this 5 here, right? So this 5 here, we are going to give it a new variable called K, right? So let's go there and see what happens. So here it means that our resulting matrix here, right, would have, so this would be IJ, right? So IJ J. Now if this is IJ, currently this I is up to 4 and then this J is up to 5, which wouldn't be so. So we would have to change this one to 1, right? Which means that in the end we want to have a 4 by 1 matrix, right, as our resulting matrix. So we can assign this to 0, and then from here we now create an inner loop for the for the column containing the 5, right? So this would be, let's say, for say another int, so let's call this K equals 0 while K is less than 5. So this time around K must be less than 5, right? And then K plus plus, right? Then so it is from this loop that we would populate. So here we would write it in such a way that our mat C, right, of I, J, right, the index I and J should be plus, so it should be plus and equal to, why? Because we said that we will perform the multiplication iteratively. We multiply the first element, here to this, and then add that result to the product of the second element, add that result to the product of the third element, add that result to the product of the fourth element, add that result to the product of the fifth element, and the total we put them as the answer or the first element of the new matrix, right? Okay, so basically that's what we are coming to do. So we add it and then equate it to the what? Now the product. So we would first have to multiply the matrix A, right? But then which elements? Now this time around matrix A is 4 by 5, right? So it's going to be, the I is from 1 to 4, and then J on the other hand, but then this time I will not put J here because J here runs is just one column, so it means it's supposed to be K here, right? And then we multiply that with the element for matrix B, but this time around the matrix B has 5 rows, so it will be K rows, right? And then J columns, right? So J column. So intuitively you realize that here this K here would cancel this K, and the resulting matrix would be IJ, as we can see here. Okay, so basically this is what happens, right? If you should run this loop, it's going to first start from here, assign I to 0, and then starts I from 0 to 3, and then inside it, while I is equal to 0, it will start another loop to J, right? And then now in this loop, what happens is this: J also starts from 0 and then to 1, right? So it starts from 0, since J is just one element, right? And then from here, while it is in the J loop, it starts a new loop with K, or for K. Now this loop will run from 0 to 4, and this from 0 to 4, what happens is that while it's at 0, which means that we have I is at 0, J is at 0, K is at 0, then we have mat C, which has its element 0 0, would be equal to plus and equal to the mat A with its element 0 0, and then times mat B's element 0 0. But then this would then, the K will then move to 1, right? And then mat A element is still that is still 0 0, but this time round it's no longer we are going to add the previous value we had. Now this element is no longer going to be 0, but instead is going to be the result from the previous loop, right? And then to add that result to the product of mat A 0 1 element and the mat B 1 0 element. So basically that's it. To take the elements from the 0th row and then first column, that's the 1st column of mat A, and multiply it with the elements from the 1st row and then 0th column of mat B, and then add that, and then this one will go to what? 2, and then it will still come back here and then do the same thing, 0th row 2nd column, and then times what? The 2nd row 0th column, just like we discussed here. So it starts from this row times this, then plus this times this, plus this times this, plus this times that, like that. So it continues that way until we get our new matrix C, right? So basically that's what we expect. So let's end this line and see what we would get. So from the ending, we can now save our work and try and see whether we would get any error while compiling. So GCC mathmo, we want the output to be mathmo.x. okay, we don't have any error. So when we run this code, right, mathmo.x, nothing shows because we didn't print it, but that doesn't mean that the multiplication didn't happen, right? So now we would have to print the output for the printing what? The output or the elements of math C, right? Now to print that, we said we'll use another for loop, right? But then this time around we can still use int I, right? I running from, so I equals 0, but then I is less than, we said the element in math C will be a 4 by 1 matrix, so less than 1, and then increment I, so plus plus, and then from here we do what? We decide to, now we declare another loop, so for the columns, and that will be I in, so for I, right, so j, so int k or j equals 0, right, and j is less than 1 because it's just a column. Then we said j plus plus. Now this here, we will now decide to print f, right? So print f what? The elements, right? So these are integers, so use %d, and then print the elements of math C, right? So matrix C, but then which elements? The elements from the ith and j column, the ith index and the j index. So basically that's that. Let's end this line and see, but then we want this to display nicely like a matrix for us, so we would give it a space and also print a new line after the first loop so that we see it nicely. So print f, and then we put a new line in between that, and then we save. So we can save this and then recompile our code. So we didn't bring the ending for the new line here. So now let's see what happens. Let's clear first, recompile. Now there's no error, and let's run our code. So now we have our column matrix 55, 130, 205, and then 280 to be our answer, right? So basically that's how we deal with the matrix multiplication. So sometimes the inner loops can get very confusing, so if you don't want to be confused, know that the row loop belongs to, or is responsible for, the row of matrix C, the new matrix. The column loop is going to be the column for the new matrix C, but then as well it's the column for the old matrix B. The row is also the new matrix C, and that for the old matrix A, right? But then the new loop K now belongs to the column for matrix A, right, and then the row for matrix B. So you could see that we have done it in such a way that the K's can cancel whilst leaving the I and then the J for us in the matrix C. So basically that's for the matrix multiplication. Now if we want to just transpose quickly, if we want to transpose this matrix, right, we want to transpose matrix A, if we want to transpose matrix A, all we have to do is, so let's say mat A transpose, right? Matrix A transpose. So for matrix A transpose, we can just loop through. So for let's say int I, right, equals, the mat A has 4 rows 5 columns, so int I equals 4 equals 0, sorry, and then I less than 4. We are using 4 because the index starts from 0, so we'll do up to 3 and then stop. That will be then I plus plus, right? And then from here we can decide to now we give it an inner loop, right? And this time is from J, right? J, so we declare the J to int J starting from 0 and till J less than, this time J, they are 5, right? So now we have this, and then we have to increment J to, so J plus plus, right? So now we have this. Inside this, we first have to declare a new matrix, so let's call it mat A transpose. So mat A trans, right? And then this new mat A transpose, if you transpose a 4x5 matrix, would have a 5x4 matrix, right? So this should be a 5x4 matrix. Okay, so now we have that. So once we have this, we can now enter the loop for that and then assign this. So inside this loop, we say that we should assign, so for mat A trans, right, the elements of mat A trans the I and J, right? So it means that the mat A transpose has J as its I column, row, and then Ki as its column. So we can now give it for this Ji, right, and assign it to at ig mat A what ig and then print it again to see the output. But to print that, I don't want to rewrite any loop for it, so I will just have to modify. Okay, we can rewrite a new one. Now we have that. I hope everything works well. Okay, now let's see what happens. Okay, let's okay, yes. So now outside here, let's print the new. Okay, so this is outside a for loop. Let's get a new for loop. So printing transpose. We have what? So we have for, so to simplify distance for you, you can choose to write a function, right, that would print the matrices. So that once you are done, you just call that function and then it will be printing this matrix instead of writing these loops over and over again, right? So now the row is now 5, so less than 5, and then I plus plus, and then inside that we loop again. So for int, right, j equals 0 and j less than 4, this time is 4, so j less than 4, we do what? We j less than 4, okay, then we increment j, so we increase j by 1, right? So now from here we can now print f, right, the element, so it's an integer, so d, but then let's space them out so that they will look nicely, and then of what? Math a trans, right, transpose, but then which elements? We want the I and the j elements, so I j elements of that, and then let's end this line, but then we want it to be printed nicely like a matrix, so we add a printf new line here as well to do that for us. So now we can save this and recompile this. Whoa, we have lots of errors. Let's see where's the error coming from. Oh yes, it's because we didn't tell which type of value this matrix is storing. Sorry, so it should store integers. Okay, so because of that, let me clear the screen, then recompile. Okay, there's another one here for, yes, this should be a semicolon, not comma, right? It's a semicolon, not comma here. Okay, hope this is the last error. This is why I try to compile at every small update so as to prevent being okay. So now we don't have any error, so let's run it and see and keep our fingers crossed. Whoa, so let's see, we have, what do we have here? Okay, so this interesting. So this is what happens. I think we forgot to, okay, this is a transpose, right? But then we didn't close, I guess we did not close exactly. We should have closed this matrix, this loop, so that, and then delete one down here. Okay, so now let's save again. So even though we did not get any error, this is a logical error because we don't expect it to print. It printed the first element, the transpose, the second element, the transpose, the third element, the transpose. We didn't want that. We wanted it to finish with the first matrix and then followed by the second matrix once. So let's recompile this and then rerun this. Interesting. So this is what we want. So we have 55, 130, 205. This is the product, the result from the product, and this is our transpose. So you saw that the first matrix was 1 2 3 4 row wise, but now it's now 1 2 3 4 5 column wise. So we've succeeded in transposing our matrix A and as well printing it to screen, and now we can finally do the matrix multiplication. So you can try and remodify this, try to write a function for printing the matrix so that you wouldn't be looping every time you want to print a matrix, and then try and see whether you can generalize this, try and see whether you can create your own matrix, but then this time receive inputs from the user and multiply the two matrices together. So basically that's that end. That we've come to the end of today's activity. Thank you for joining us. Please, when you enjoy this video or you benefited from this video, don't forget to like and hit the subscribe button so that anytime we release new content, you would be the first to be notified for these new contents. Thank you, and don't forget to share with your friends.